Okay, let's learn another technique to factoring. Today we're factoring by pulling out a GCF. So the essential question, now that we know how to reverse FOIL, this is what we did in class, right? Where we kind of went backwards of FOIL. How can I factor by reverse distributing? Interesting. And this is where we'll pull out a GCF, and we'll talk about what that means. Just a reminder, reverse foiling means, hey, I'm going to take this and I'm going to turn it into two sets of parentheses multiplying each other that multiply back to here. I'm going backwards. Definitely I need an x and an x because x times x gives me the x squared term. But I need to find out what numbers to put in the last place of each binomial. And remember, we had a pattern for this. It was numbers that multiply to negative 36 and add to negative 9. Doing that kind of is what FOIL is doing. And so if I find those numbers, I'll be good to go. So if we just start listing some ways to multiply to 36, I know that because of the negative, one of these numbers will need to be negative. So like 1 and 36, maybe like 2 and 18, 3 and 12. And oh, let's just stop right there because 3 and 12 is interesting. I know that one of these needs to be negative so that I can multiply to the negative 36. So if I have, for example, negative 12 and positive 3, that's the combination that also adds up to negative 9. Negative 12 plus 3 is negative 9. And so this is my answer. Remember that I can always check by just doing the FOIL. So let's see, x squared, 3x, minus 12x, minus 36. Yes, these two do combine to negative 9x. I'm good. Okay, so that's factoring. I'm going backwards. So today we're doing a different kind of factoring that has to do with distribution. It's doing distribution backwards. So just a reminder of how to distribute. I'm putting this in here and here. It's like easier foiling, right? It's what we did back before the days of binomials multiplying each other. So first, 3m squared times 3m to the fifth, multiply coefficients, add exponents, done. Next, 3m squared times negative 1, well, that's just negative 3m squared. So this is distribution, right? So what we're doing today is we're doing backwards distribution. So we're doing factoring by pulling out a GCF. Notice, this doesn't look anything like our reverse FOIL factoring. There's only two terms. There are two different variables involved. It's weird. So in order to reverse distribute, so I'm starting here and trying to get something to look like the original problem, I need to figure out what the GCF is. Now, hopefully you remember that GCF stands for greatest common factor. I usually just say GCF because I don't want to say greatest common factor every time. It is a mouthful. The greatest common factor is the biggest thing, I'll call it a thing, and a thing, or the biggest term maybe, coefficient and variable that I can pull out of both of this and this. So here's what I mean by that. I'll just do an example and I think you'll see what I'm getting at. The biggest number that goes into 12 and 42 is 6, right? Because if I divide 12 by 6, I get 2. If I divide 42 by 6, I get 7. 6 is the greatest common factor of 12 and 42. It's the biggest number that I can divide out of both of them. And I should also see if I can pull a variable out of both of these. So x, y. If I try dividing by x, yeah, I'll be left with no x's. But if I try dividing by x over here, that doesn't work because there's no x in that term. So actually there are no variables in my GCF here, but there will be in future problems. So maybe I confused you by saying that. We'll get to some examples where there are variables in the GCF later on. Anyway, the point is once I've pulled out a 6, I need to see what's left over. So when I divide 12 by 6, I'm left with 2x. When I divide 42 by 6, I'm left with 7y. Now, notice how I have a problem that now resembles a problem that's set up to distribute. So this is my final answer. I actually distributed out a 6. My pen, the eraser is not working very well. point is that in order to check my work, I simply need to distribute back in this 6. So when I distribute back in the 6, I get 12x plus 42y. This is my original problem. Awesome. Okay, so let's look at the next one. So here, I need to figure out the GCF. So let's figure out the GCF of the numbers. And I think clearly here 4 is the biggest number that I can divide out of both 4 and 24. But let's think about the variables, because this one is one that the GCF actually does involve a variable. I need to think about what is the kind of most number of variables that I can pull out of both terms. So let's think about this. If I divide out all 4 of the x's from this term, I'm good, because it has 4 x's that it can kind of give up. But if I pull that same 4 x's out of this term, it only has 3 x's to give up, and this doesn't make sense anymore. It does not have 4 x's to give. So I can't pull out 4. But if I only pull out 3, take a look at what happens now. If I pull out 3, well, this guy really does have 3 to give. And if I pull out 3 here, yes, he has 3 to give also. So x to the third is the highest power of variable that both terms can give up. All right, so when I pull out 4x to the third from the first term, I've pulled out the 4, it's now just 1. I don't even really have to write it. And I've pulled out 3 of the x's, 1x remains. When I pull out 4x cubed from this second term, I'm left with 6, and I'm actually left with no x's because I pulled out all 3 of them. So this is my final problem. Now, let's just check our work, distribute back in. When I do 4x cubed times x, that gives me 4x to the fourth. When I do 4x cubed times 6, that's 24x to the third. I'm good to go. All right, we'll go through the next 2 examples a little more quickly because I think you're getting the point. This next one, okay. The biggest number I can pull out is 2. The highest power of x I can pull out is just 1x. Because this guy only has 1 x's. If I were to pull out 2 x's, this guy does not have 2 to give up, and so it doesn't make sense for him. So I pull out 1x. When I pull 2x out of 2x squared, I'm left with just x. When I pull 2x out of negative 8x, I'm left with negative 4. Final answer. I'll let you to check yourself. Final problem. Okay. 3 is the highest number I can pull out. This guy has 2 m's to give up. Even though this guy has 7, since this guy only has 2, the most number of m's I can pull out is 2. That leaves me with, let's see, that leaves me with a 3 and then 5 m's, because remember when I pull 2 m's out of 7, there are 5 left. Also notice that this problem is totally one that we did last chapter. I'm just subtracting the exponents to get 5. Also, when I pull 3m squared out of negative 3m squared, does that just go away entirely? Is this my final answer? Well, no. Remember, when you divide something by itself, you're left with 1, or in this case, negative 1. Okay, so distributing back in, yes, that would give me 9m squared. Yes, that would give me negative 3m squared. So I'm good to go. If only my pen were. I'll probably be complaining about that for many more videos. Let's just hope it lasts to the end of the year because I do not believe I can buy one of these in Morocco. It would be very sad. Oh, anyway, I don't need to ramble. Here's your quick summary. Determine the GCF by finding the biggest number and the biggest power of x that can be divided out of every single term. When you have the GCF, find what is left over after you have pulled it out. That you will put in parentheses. It's like reverse distribution. Thanks for watching.